Alright, this video is on Avogadro's number. In it, we're going to talk about the value of a mole, the definition of a mole, the difference between the different types of particles, mainly formula units versus atoms versus molecules. And then we're also going to do some example conversions, converting to moles, converting from moles, and then using mass in the examples as well, based on your previous worksheets. So we'll go ahead and start with Avogadro's number. The number itself is 6.02 times 10 to the 23rd, and I put particles in parentheses and quotes. These particles, they can involve atoms, they can involve molecules, and they can involve formula units. Okay, those are the three types of particles that I'm referring to, and I'll differentiate between the three of them later. And then one thing you definitely need to write down is the definition of a mole, which is the amount of atoms of carbon in 12.01 grams of carbon. So, period there. So make sure you grab the definition, and then first thing we're going to talk about is differentiating between atoms, molecules, and formula units. Alright, so here we have a lot on the screen. If you want to go ahead and pause the video so you can kind of write everything down. I'm going to go over atoms, molecules, and then formula units. So an atom is anything that is just one of something. So if you notice, the helium, the zinc, the silver, the xenon, none of those have any subscripts in them. They are just the individual, just the elemental symbols. And if you ever come across anything where it has just the elemental symbols and no subscripts, no combination of more than one atom, then you would just say that those are atoms. So 1 mole of, say, for example, I don't know, 1 mole of cobalt, there would be 6.02 times 10 to the 24 atoms of cobalt. Or I can exchange cobalt in with any of these 4 examples up here: helium, xenon, argon, silver, gold, okay, platinum, titanium, whatever. Okay, so 6.02 times 10 to the 23rd atoms of just those individual, those different, elements that are on the periodic table: calcium, strontium, whatever it is. If there's no subscripts, it's just an atom. Now, molecules like water, methane, hydrochloric acid, HCl, those are all molecules. And the reason why they're molecules is because those are all compounds that are covalently bonded. Or at least how I like to think of it as, these are all nonmetals that are connected to each other. Okay? Your nonmetals include hydrogen, helium, nitrogen, carbon, oxygen, fluorine, neon, phosphorus, sulfur, chlorine, argon, bromine, krypton, selenium, iodine, xenon, and radon. Now, if you have a combination of those chemical symbols with little subscripts in them, or even no subscripts, I just have a combination like I have over here with my HCl, that is a molecule. Now, it can be the same symbol. For example, O2, right? That is a combination of more than one atom, but those 2 atoms are both nonmetals. So, because they're 2 oxygen atoms. And since they are 2 oxygen atoms and they're 2 nonmetal atoms, it falls in the same category as a molecule. So if I had a mole of oxygen gas, the O2, if I had a mole of water, if I had a mole of methane, if I had a mole of hydrochloric acid, I would say that there was 6.02 times 10 to the 23rd molecules. Okay? Now, formula units are pretty much anything else. Okay? Anything that is not a molecule and not an atom, we would call a formula unit. Okay? And a good way to identify what it is it tends to have a metal in it. So like sodium's a metal, calcium's a metal. If I was to, say, put, I don't know, copper iodide, okay, or copper 2 iodide, um, that has a metal in it. And because it has a metal in it, then you would say it has a formula unit because both copper iodide and silver and sodium nitrate and calcium chloride, those are all ionic compounds. So if it has only nonmetals, then it's a molecule. But if it has um, something that is not a nonmetal, not among the list of elements that I had just mentioned to you, the hydrogen, helium, nitrogen, oxygen, fluorine, neon, phosphorus, carbon, sulfur, chlorine, argon, selenium, bromine, krypton, iodine, xenon, and radon, if it's not one of those guys and it has any of the other elements in it, it's going to be a formula unit. So for example, if I had 1 mole of copper iodide, it would be 6.02 times 10 to the 23rd formula units. But then again, I can use silver nitrate in there. I can use titanium fluoride. I can do iron carbonate. Any of those, they would all be formula units because they are not molecules and they are not atoms. Now, the reason why I feel the need to distinguish between atoms, molecules, and formula units is because the worksheets that you have, they may say how many molecules, or they may say how many atoms, or how many formula units. Well, it's nice to know what these words mean. So, for example, okay, we'll do one quick problem, or better yet, 3 quick problems. Okay, so these are the 3 types of problems we have. That kind of differentiates between those atoms, molecules, okay, atoms, molecules, and formula units. But if you notice, I'm doing the same thing in each step. It's just I'm calling my final answer something different because of the nature of what I'm finding. Okay, so if you look at the first one, the number of atoms of gold in 2 moles of gold. So I have 2 moles of gold right here in the first step. Okay, and then in the second step, I have 6.02 times 10 to the 23rd atoms, okay, atoms of gold over 1 mole of gold. So my moles will cancel out, and I'm left with atoms of gold. So my final answer will be atoms of gold, right? Whatever that number happens to be, it's 1.20 times 10 to the 24th. But if you notice, they're doing the problem all the same way. Look at the second one. Moles of nitrogen disulfide. Moles of nitrogen disulfide cancel out. But because nitrogen disulfide is a molecule, it's made of 2 nonmetals, then I call it a or it's made of nonmetals, I call it a molecule. So my final answer will be in molecules of nitrogen disulfide. Last one, number of formula units. Okay, it's the same problem again, but my moles cancel out. Okay, and I have formula units of silver chloride. So my final answer would be formula units of silver chloride. But if you look, even the answer itself, the units may be different. Okay, I have atoms here, and I have molecules here, and I have formula units here, but my answer, my number, will be the same. It's just the type of unit's different based on what chemical or substance I'm looking at. Okay, so that's the difference between atoms, molecules, and formula units. It's not so much going to affect how you do a problem, it's just going to maybe help you how to interpret a problem. So let's do a couple extra example problems. Okay, so the number of moles in 5.23 times 10 to the 24 atoms of nickel. Okay, so the last problems we looked at the number of molecules or the number of formula units or the number of um, atoms in a certain number of moles. Now I'm doing the opposite. I'm trying to find out how many moles I have based on this many, in this case, atoms, because it's just the symbol. So, do my problem. I start with what I'm given, always, 5.23 times 10 to the 24 atoms, nickel. Remember, you need to always include your chemical in your chemical formula or chemical symbol in your dimensional analysis. and I know that I need to get rid of atoms, so 6.02 times 10 to the 23rd atoms of nickel go on bottom, and that's 1 mole of nickel. Atoms of nickel cancel out. I'm left with moles of nickel. Enter it into my calculator, and my answer is 8.6877. Of course, looking at sig figs, in both cases I have 3 sig figs, so this number changes to 8.69. Okay, because I need to look at this number to determine what I do with that one. And my unit is moles of nickel. And that's my final answer. So far, I've given you an example of going from moles to atoms, or moles to formula units, or moles to molecules. And I've just given you an example of atoms to moles. Now, if I had, instead of nickel, I had oxygen gas. And then this wouldn't be atoms, it would be molecules. But understand that the problem would still be set up the same way, it's just I would use different words. Okay? Or if I didn't have oxygen, I had sodium chloride. And this would be formula units. I would still set the problem up the same way, it's just I would use different words based on the type of chemical that I have in the problem. Okay? Couple more problems that I want you to include the mass, and you need to use the molar mass to solve your answer, or solve your problem, so to speak. So, looking at this problem, how many molecules are in 15.2 grams of ammonia? So, whenever grams are involved, you need the molar mass. So you look at the periodic table, you do your 1 nitrogen, your 3 hydrogens, you end up with 17.04 grams for every mole. Right, so there's my molar mass. I'll use that. Okay, so I start with what I'm given. 15.2 grams of NH3 over 1. Then I'm going to go ahead and move it down a little bit because I have my molar mass in the way. I need to get to moles because I don't have a direct relationship between molecules and grams, but I do have a direct relationship between moles and molecules, so I can do Avogadro's number to get there. But first I need to get to moles. So I'll put 17.04 grams of NH3 on bottom with 1 mole of NH3. And now, if I was to cancel out, my grams are canceling out, and then I'm left with moles of NH3, but I don't want moles of NH3. I want molecules of NH3. So I'd have 1 mole on the bottom, NH3, to get rid of it, and then I'd have 6.02 times 10 to the 23rd molecules NH3. So now my moles cancel out. I have my molecules of NH3, which is exactly what I want. I do my math. I end up with 1.56 times 10 to the 26th molecules NH3. Okay, so there's my answer there. Alright, probably squeeze in one more. Alright, how many grams are in 2.51 times 10 to the 24th formula units of calcium oxide? So first thing I want to do is start with what I'm given. Okay, so I'm going to go 2.51 times 10 to the 24th. I'm going to abbreviate formula units of CaO, and then I put that over 1, and I know that I have 6.02 times 10 to the 23rd formula units of CaO. Okay, the reason why I'm doing this is so I can get to moles of CaO. Okay, and I'm going to go ahead and continue down here. So if I have moles of CO on top, or CaO on top, I need to have moles of CaO on bottom, and I need to get to grams of CaO. Where would I find the molar mass of calcium oxide? I would look on the periodic table, and I get 56.08 grams of calcium oxide. So my moles will cancel out. My formula units of calcium oxide will cancel out. I'm left with grams, which is what I want. So I do my math, and my final answer is I multiply across 2.51 times 10 to the 24th times 56.08 to get 1.41 e to the 26th grams of CO. I divide that by 6.02 times 10 to the 23rd, and I end up with 234 grams. Make sure I maintain my sig figs throughout. All right, if you guys have any questions, please make sure you ask. You have 6 problems for your homework on conversion worksheet 3.